All right. So in this section, I'm going to use the 3D printer program that comes with it. For me, it's the Anchor Make Studio, which is based off Prusa Slicer. Now, whatever printer you have, you should probably use the same slicer that came with it, and probably have very similar settings. I've used a bunch of different slicers, and the functions might be named differently, but they do the same thing essentially. So we'll go. I've imported the model that we've designed. Now, in the other video, I actually was segmenting the left-sided mastoid, but in this case, I'm going to use a right-side mastoid just because there's an interesting quirk of that CT scan where the patient did have an osteoma. And so I spent more time finessing that model in the external auditory canal. So anyway, this model, I included obviously the mastoid, ear canal, styloid process, foramen lacerum with the whole path of the carotid artery. It goes up, horizontal segment, then comes out here. Sigmoid sinus, as you can see, comes down and then goes back up here before going to the jugular bulb. Internal auditory canal here. And that's our temporal bone. So now you want to be looking at the settings. So I use a 0.6 millimeter nozzle, makes printing faster. I also 0.2 layer height is reasonable. You can use 0.15 also, is also okay. It just will take a little bit longer to print. 2 perimeters means that your wall thickness is going to be 1.2 millimeter. And that's about it for here. For the infill, you should do 100%. There's a publication where they've looked at the best infill and they said 98%. So I'm not sure how they reached that number, but and I've tried 99 and 98 and 100%. They're pretty similar. I would say that when I've used 99, actually I've used 98 and I've used a cubic, I'll slice it for you and you'll see what I mean. The infill of the solid bone will have a different texture. It'll have the texture, a cubic texture. I'm going to show it to you here. So basically, you're going to have that texture. Now, it is helpful to some extent when you're drilling that bone because then you know you're in infill, you're in solid bone. And then the texture will change once you get to a wall, like the wall of a cell, for example, because the wall of a cell, as you can see, there are 2 walls. So there's an inner wall, outer wall, and the texture changed. So it's kind of like in real life when you're drilling a temporal bone, where the temporal bone has different texture. The bone has different texture. When you get close to the sigmoid sinus, the color changes. When you get to a cell, the color changes. When you get to the tegmen, the color changes, the pitch changes. So it's not a bad idea to have it like that. And I've drilled some bones that were like that, and that's not a bad idea. But I also think that it's not a bad idea to try with a rectilinear pattern for the infill, make it 100% because technically the bone is 100% filled with bone. The other thing is that the skirt and brim, so what's skirt and brim is just, it helps with the adhesion, especially the first layer, for the first layer, not especially. And I'll show it to you in a minute. And then support. So ideally you want to get a model that doesn't need support, and there's a few specimens of temporal bone that don't need support. But then you have, for example, a truncated styloid process in a way that it would print a bit differently and not need much support. But in this case, where I included all these overhangs, like these horizontal portions, just to follow the carotid artery, you're going to need support. Now, when you do support, I suggest you paint the support, because if you do just automatic support, it's going to do supports everywhere all the way up to here, and you don't really need that. It's not necessary. The other thing you have to make sure that you have checked is support on build plate only, because you don't want support on your model. First of all, it's going to degrade the quality, but the second thing is that it's going to create support for the inside, for example, in the middle ear or the ear canal is going to make supports inside. You won't be able to remove them in post-processing. So just outside support. Organic, and I usually like to paint the support. So you use paint on support. I will look here and I will just paint these areas that I know are highlighted. The other thing is, just want to make sure I don't get anything inside. So here, there's inside. So I'll just remove it. Let's remove all of this. And then paint just the outside. All right. And I'll show you what I mean. Highlight overhang. I don't know why I didn't highlight it. So I want to everything above 65 degrees of overhang being highlighted. So, all right. I probably need to add some support here. Here we go. So I'll go back. The rest of the settings, the speed depends really on the material you're printing. Just follow the instruction on the specific filament that you're using. PLA on these printers can print pretty fast. The faster you print, the lower the quality is going to be. And I think middle of the road. So this printer is capable of 500 millimeter per second. So I use less so I can get a better looking model. But you should play, you know your printer, you should play with the settings on your printer and see what works best for you. So I will now slice it. All right. So we can look at the slicing, and you can see it's like a CT scan essentially. You can see the air cells. The red is infill, solid bone. And I think I still managed to get these supports here going into the model. This I probably can remove, but could be difficult to remove. All right. So that's why it's critical you get your supports properly done. And then you send for printing. Now I'll show you how it looks like because I printed it. I'm holding the stylet process. And that's it. 3D printed temporal bone. You can see the internal auditory canal here, the sigmoid sinus, mastoid, external auditory canal. It looks pretty good. And I'll show you now when I've drilled something similar, how it looks like. That's all for now.